slab size. Active heat dissipation is constant. A small steel cannon of 10,000 lumens. Compare this to a car headlight. It's very efficient. Ordinary LED light efficiency is only about 100 lumens per watt. 60 watts means 15. Then let's be more luxurious. Just use 32 2 watts each. That should get you up to 190 lumens per watt. So it took a while to get started, and I drew the board for this flashlight. This time, the component density of this board is very high because this board is relatively small, only 3 by 6 centimeters. This is the IP 2369 chip of Yingyi chip. It supports 45 watts of Type-C charge and discharge. Then this is the FP 72091 boost chip. This boost path supports up to 80 watts of power. This is the main control of the board. PY32F03. Its biggest feature is that it is cheaper, a few cents a piece. I have proofed this board back. And then there's this aluminum lamp board. Let's start welding the board. Print this paste on the board first. The effect of this printing is still very good. Then arrange all the components above. This process is very boring. After the originals are laid out, the heating table is turned on. After this main board and light board are welded, this is what it looks like. Next, flash the firmware into the main board. Because the main board is so small, I can't fit that burning socket anymore. It can only be pushed up with this burning probe. Okay, the target chip has been connected to the open brush. Then the firmware has been swiped in. Connect the battery, see if it can be charged normally. You can see that the charging power is 38 watts. The charging function is normal. We wait for it to be fully charged. Then try the efficiency of that boost. Turn it on. This is 3 watts. Here it's 30 watts. This is 60 watts. I did the math. 30 watt hour efficiency is about 94%. 60 watt hours is about 92% efficiency. What do you think of this efficiency? Next, start assembling the flashlight. First, install this 4-wire small fan on top of this radiator. With this turtle juice. Install the light board on it, then squeeze out the excess silicone grease. Clean up the excess silicone. Then fix this light board with high temperature tape. Next, install the main board, because the main board doesn't generate much heat. So just stick it on with this thermally conductive double-sided tape. It took a while. I installed the main board. The strip is the temperature cable. Then this fan turned out to be full. I changed it to 3 lines because there is a speed line that is not needed. Plug in the battery and test it. Long press to turn it on. Short press to switch gears. That's 60 watts. The fan is also rotating normally. Then I also modeled the shell of this flashlight. This is a lamp holder. This is the handle. This is the top cover. This is the tail cap. Then there's the button. This is the mold for that reflective cup. This was developed by a brother in a group for me with software. Like the reflective cup of the original Optical 200, it is a cone. Its shape can be obtained through simple calculations, but this won't work. Its shape is too complex. Without the shell, I have printed it out. Next, install this hot melt nut. Stick this reflective film on. What about the protective glass of this flashlight? I'm going to cut the lens of this camera UV mirror with a glass knife. These lenses are cheaper, and it has an anti-reflective and anti-fouling coating. I have cut one and put it in this top cover. Install this top cover on. And what about this part of the lamp holder? You're done. Next, start installing the handle part. This is 2 strings of Shunting and JT40s. I have installed the protective board, then I'm on top of the battery. And this tail cover has this buffer foam pasted on it. It can reduce the impact force of the battery when the flashlight falls. Next, assemble the lamp holder and handle. I also pasted a buffer foam here on the lamp holder. In this case, it will be resisted by this handle here. This way, there will be no displacement. Then this flashlight was already assembled. Measure its weight. 325 grams. Since it is said to be a constant 60 watts without downshift, then of course I have to test it with roast chicken. So I took it apart again. It's connected to an ammeter. It is convenient to check the data when roasting chicken. Love, love, love. Finally, under the 60 watt gear measured, its battery life is about 27 minutes. I'm using a 4000 mAh ZP40 battery. If you use 5000 Ma3C5S, then it should last a little longer. After testing, when this LED is 60 watts, the temperature is about 60 degrees. But because the shell has this 3D printed holo insulation, so it's not hot to the touch.